My name is Jarboe. I am the director of the Iowa NSF EPSCoR project. So typically, as the PI of a research grant, I would be overseeing the research itself in terms of mentoring graduate students and postdoctoral researchers, making sure the experiments are being done safely and correctly within the experimental guidelines. Here as the director, I do have a research project, but I'm also overseeing the execution of the entire award. So that means supervising staff, overseeing the subawards. So it is still research, but there's a lot more administration to it than what I am used to on other grants. So this semester I'm not actually teaching anything in order to help get the EPSCoR project launched. Sometimes I teach the material and energy balance course for chemical engineering sophomores. That deals with the inputs and outputs of various processes and estimating the energy demands for that. So for NSF EPSCoR, we are looking at biomanufacturing, and so that means producing things with biological platforms instead of petroleum-based processes. So looking at these ins and outs using biological materials instead of traditional processes, it's related to that. Sometimes I do separations. I teach the separations course. That deals with product recovery. Product recovery is part of the core research in the PAM focal area, the plastics for additive manufacturing, where we're going to be producing certain molecules, but then trying to come up with ways to separate those in a cost-effective manner, recover those from the fermentation broth for downstream utilization. So several years ago, there was a statewide competition for leading the next submission to this funding program. So we had a group of 5 faculty who were involved with that. We wrote a pre-proposal, and then we submitted that for the state competition. There were several other ideas that were submitted to that pre-proposal that were viewed as attractive for the state. So they asked Tim Kidd, for example, at University of Northern Iowa, and Hong Tao Ding at the University of Iowa. They brought their expertise to the project, and so we spent a summer combining those ideas, and then we proceeded with developing and submitting the full proposal. The thing that interests me most is the workforce development part. And so we're here to educate students, right, to educate the future workforce. And Iowa has a population problem. We do have somewhat depletion of the workforce. We don't have enough people to fill all the available jobs. So broadening the workforce, enabling participation from groups that are historically underrepresented in STEM, I think that's a great thing to do. And I'm very proud of the activities that we have planned as part of the workforce development efforts. My goals for the project is I hope that at the end of this we've been successful in terms of expanding research capacity in the state for advanced biomanufacturing. Some of that means purchases and installation of new equipment, the workforce development components, broadening participation, and also building sustainable research collaborations between researchers throughout the state of Iowa. One of our key themes is bringing biological researchers together with advanced manufacturing researchers. So getting those two groups to work together so that we can produce, for example, plastics for use in additive manufacturing. The goal is to build sustained collaborations that continue after the project ends. At the end of the project, I hope that we have had some success with our research, not just in terms of training graduate students and publishing papers, but that we have some technology that is of interest to possible industrial partners. I also hope for the results of our broadening participation efforts in terms of being able to identify strategies to expand the biomanufacturing workforce in Iowa so that we can continue to be a leader in meeting human needs with things that grow.